let's get started. So welcome everyone to our April meeting of New Mexicans for Science and Reason. I'm Dave Thomas, our president. John Covan, our hardworking vice president, is in the house. I'm sure you've heard by now that our former president, John Cohegan, passed away early March. So there will be some kind of ceremony about that, probably around June, when John's family can arrange to be there. So I'll keep you posted on that. In the meantime, we're delighted to have our guest, Professor Mostafa Hassanalian, Associate Professor of Mechanical Engineering here at New Mexico Tech in Socorro. And he's part of the Autonomous Flight and Aquatic Systems Laboratory. And his research areas include biomimetics, bio-inspired aerial and aquatic robots, design optimization performance of aerial vehicles, drones, fixed wings, flapping wings, rotary wings, tilt rotor. This is fascinating. Morphing drones, space and marine drones, separation and swarming flight of micro drones, new concepts for planetary and space exploration, and aerodynamics, hydrodynamics, aeroelasticity, fluid structure, interaction. So that is an amazing portfolio there. So without further ado, do you have like a presentation? I can make you a co-host.
Yeah, I can.
Excellent. So let's do that. You have been anointed with the co-host sauce. So
all right, great.
Thank you for joining us.
Thanks for having me. So hello, everyone. Thank you for inviting me for this presentation. So I think I have met you, David, in our department. You are teaching in the same building that I am, and I know Mark through the AIAA.
Well, fascinating. Yeah, I saw your article in the paper recently about your drones, and
I will talk about that, and I have some videos for this project as well. So I have about 100 slides, but I'll try to make it like focus on the area which I think is probably more interest of you guys. So do you have all my screen?
Yeah, it looks great.
Right. So my research area here at New Mexico Tech since last 5 years that I'm here, it's about drones, bio-inspiration, biomimetics. So it's basically, once we talk about drones, there is a huge classification of the drone technology. And this is one of the paper that I published when I was a PhD student. It has got like about 1,000 citation. It's about different configurations of drones. So once you talk about drones, everybody is thinking about fixed wing drones or about multi-rotors, quadcopters, and those type of things. But actually it's more diverse, and there are more shapes, more configuration, different sizes, different weights. So for example, in this classification that you will see, we have insect-sized drones that are in the size of the insects and mimic the way that the insects are flapping. Or we have the bio drones, which I will show at the late on one of our project, which was out there in the media last 2 months, which is about making a taxidermy dead birds flyable again and re-engineer the dead birds and make them as a drones. Or you see here a beetle, which it can be controlled as a live insects, which you can control it with basically a remote controller, send some pulse to the muscles or to the nerves and control them as a drone. So this was a project in 2011 funded by DARPA in University of Maryland. So drones by themselves, they have more than 200 applications. So depending on the area that they are flying. So for example, if they are in the outdoor or indoor space, or we want to have a drones that can dive into the water and swim under the water, or they can land over the water, the drones that they can fly in the other planets. Which this is basically half of my research right now at New Mexico Tech is drones for planetary exploration, which I'll talk about that more. So this is another work that we recently published is about matching between the configurations of the drones and applications. So for example, we want to have a firefighter drones. We want to have a drones for inspection. We want to have a drones with a higher endurance. So what is the best configuration for a specific mission? So here we actually mapped and classified drones to 4 different categories based on the flight mechanism, including the horizontal takeoff landing, vertical takeoff landing, the hybrid drones, which they are mixing those 2 flight modes, and the bio-based drones, which I'll show you more, which is the core part of my research, which is biomimicry, that how we can learn from nature and apply those lessons learned from nature to the drone technology to develop new types of drones. So here to just show you the applications of the drones, one of my former students' projects that we did was the combination of the drone technology and fashion industry. So our project was looking at the butterfly inspired drone, which we can have a swarm of the butterfly, which they can follow a celebrity in the red carpet for the Met Gala event. So that's probably one of the projects that nobody can imagine that drones can have this type of applications. So is basically having the butterfly drones can fly around the person. So here at New Mexico Tech, I'm also advising our AIAA Students Club, which every year they go to a competition through the SAE or through the AIAA DBF. This is one example that their students, they build a drone, they need to assemble the drones in less than 2 minutes and just fly it during the competition. So biomimetic and bioinspiration, these are the 2 terminologies that this is a class I actually have developed from like middle school students to our graduate level, that how we can learn from different types of locomotion that happens in the nature and develop some new systems for drone technology or for different types of robots, which they are more efficient than like the current engineering system that are available. So biomimetics and bioinspiration, there are 2 different terminologies. So this is a question I always ask from my students, that what is the difference of these 2 words? Bioinspiration means that you look at the nature and you try to inspire from nature and develop some sorts of like engineering system. So for example, airplanes, they are bio-inspired because they looked at the birds and they learn how birds are flying and they came with the airplane design. But if you look at like flapping wing drones, this is a bio-inspired biomimetics because you are trying to replicate the nature. So all of these concepts that you will see it here, all of these robots and drones, they are biomimetics. So it's basically, this is the snake-like robots or the butterfly or dragonfly, they are mimicking exactly what's happening in the nature. So the other question is that, is biomimicry always optimized? The answer is no. Because if you look at the underwater system, if they're like a killer whales, dusky dolphin, or fishes, if they had an engine and propeller, they were probably more efficient than having a fish-like robots or fish-like motion. But again, the question is, this depends on the scale. So for example, if you want to develop a drone in the insect size, it's much more efficient if I make a drone that is mimicking insects or flies or mosquitoes rather than having a fixed wing. So I'll talk more about that later on for other concepts. So I want to show you this aspect. So here you will see 9 different species. The first one is the dandelion seeds. So dandelion seeds, they can fly up to 100 miles through the winds. The second one is a pillbug, which they can basically roll, they can crawl, and they can curl. So the other one is a jellyfish, which are swimming underwater. This is a spider called golden wheel spider. This is found in the deserts in Namibia, which is rolling and jumping once they are in the downhill or they are in the presence of predator. In order to save energy and escape faster, they start to roll and jump. This is a grasshopper, which they are jumping. Insects, this is another spider. It creates a web, launch the web to catch insects. You will see the tumbleweed that are wind driven through the wind, is just dispersed in the environment. This is a these are the bacteria or microorganisms that are using the flagella based locomotion in order to swim in a high viscous fluid. And this is a killer whales can eat a bunch of fish in the same time. So now I want to show you what type of project here at New Mexico Tech we have been doing, mimicking this nature. So here, this is a spider robot that one of my former students, she actually worked on this to develop a robot with the rolling and jumping capability. And we proposed this for Martian or lunar exploration. So if you look at the on most of the rovers that NASA has sent to the Mars, all of them, they have the crack in their wheels. And this happens because of the rocky surface area on Martian environment. So the concept that we have been working on is to developing a swarm of this type of a smaller robots that can carry sensor, but they can roll and jump similar to that spider. So this is some of the prototype that we have been working on with these characteristics. And we have done lots of modeling about their dynamic stability and also how this can work in the different environment, like in the lunar environment or in Martian environment. So this was one of our undergraduate project. We actually participated in NASA competition 2 years ago, and within 35 university, we actually scored, placed the first and second in our engineering paper, and overall between 35 university across the country. And the concept that we proposed was having a grasshopper jumping robot, a swarm of them for lunar exploration for Artemis mission. So if you look at the moon, there is no any atmosphere there. So we cannot use regular drones there. And one of the big challenges is a lunar regolith. So the concept that we are trying to develop is a jumping robot. So these are the robots that they can easily jump in the lunar, and they can gather information. Is easy from the energy perspective, types of robots, which they can be more efficient than other types of the track-based or wheel-based robots that they are currently designed for lunar exploration. So this is our this year competition. We are actually participating again. This is a robot we have developed similar to a roly-poly. In January, we presented a paper about this in the AIAA SciTech, and NASA JPL become really interested in this, and they're actually going to send somebody here at New Mexico Tech to look at this robot, and we are going to present it to them about these concepts. So this is another like type of bio-inspired concept, mimicking roly-polies or pillbox, which they basically can roll, and they can once they're in the down hills or in craters to save more energy, and or they can walk, they can run, and they can curl. So this is one of the concepts that currently we are using this for another application, which I'll talk about that shortly. So at New Mexico Tech, we have, I am leading a team of like 40 students that are participating in NASA Lunabotic competitions, which one of the requirements is to have a lunar arena in our school. So this is a simulated lunar environment with the trains that we have created here in order to look at the locomotion of this type of robot in this controlled space, which I'll show you more pictures of this. So here there is a like jellyfish inspired drone with a helium gas field, which can carry multiple small robots. This is right now not flyable, it's a little bit heavy, but we're currently working on that and work with a Sky company, which they are doing an airship stuff. And I have a project with them trying to develop this type of concepts as well. And the main applications these are the lightweight, using the same propulsion mechanisms that jellyfish are using, and use the same concept of the propulsion in the air with having a lighter than air concept like this. So these are like some of the underwater robot that we have developed, which are mimicking the flagella-based robot or micro bioorganisms, which they can be deployed in the water, and they have the rotating tail, and they will allow them to swim under the water or in a high viscous atmosphere. And this is one of our new projects that we have been doing. This is basically a bio-inspired and cultural inspired drones. So once I talk about culture, I have a project pending with the NSF, and we are looking at developing the culturally inspired drones, which they can have variety of applications. So for example, so this is coming from the Navajo culture. Is basically they are talking a lot about the dandelion seeds, which they can be dispersed. They can fly like 100 miles or 150 kilometers through the wind. It just can disperse in the atmosphere. So for this concept is basically we have a prototype multiple example of this. This one has a weight of 0.3 grams, and this has a weight of 5 grams. Equipped with a small solar panel and a small electronics, microelectronics. These are the sensors that have a sensor of like temperature, humidity, pressure sensor, gas sensors. And I'll show you why we are developing this type of technologies. And they don't need energy. They just disperse in the atmosphere. They can collect energy through this solar panels or through the vibration with the new concept, the model that we are developing. We are using the piezoelectric transducer, which with this vibration of this structure, they can harness energy and they can provide energy to a sensor and to the communication systems, which are using a backscatter communication in order to provide micro like watts to the system for communication. So the way that the dandelion seeds that are flying is really interesting. They usually create a vortex ring above them, which would allow them to stay in and float in the air. And this simulation also shows that how if they vibrate during the motion, how this vortex can happen and how this would allow them to generate lift, but in the same time they can basically fly and harness energy. So I showed you some concept, and this is one of the combination of this research is having a drone which can carry this pillbug robot, drop it, and then this pillbug robot will be able to disperse plenty of those dandelion seeds. And I'll talk more in the next slide about why we are doing this. And this is the smallest one, is 0.1 grams that is flyable, and it can be dispersed in the wind speeds. So this is like a bunch of example with different robots. This is one of them, and this shows that how they can be dispersed. The one thing that right now we are doing is optimization of the shape. So it's basically this shape would allow them to fly, or once they are dropping or they're flying, they fly in a straight mode. So we will have them in a way that we want. And this is one of those hexapad robot that we have built in order to show this proof of concepts for these dandelions dispersal systems. And here we have another types of fans which can collect them if they are dropped. And I'll talk more about the main applications that we have for this. So about half of my current grad students, they are doing drones for planetary explorations. So Titan, Venus, Moon, underground spaces or subsurfaces, Earth and Mars. These are the only planets and moons that we can have a potential flight or robots there. So these are all the drones when I designed and built them when I was in a college. So there are like different types of the like tip rotor drones, fixed wing microaerial vehicle, different types of flapping wings here. And these are the one that we have built here at New Mexico Tech. And this picture shows all those concepts that we have developed here. So Venus, my former grad student is currently working in San Diego National Lab. His project was to develop a drone which can fly on Venus. So NASA is really interested to have a flight in the mid-altitude on Venus. So Venus has extreme conditions. So if I show you a short video of Venus, extreme condition means that high pressure, high temperature, acidic environment, and in some of the altitude, high-speed winds. So we have been looking at having energy harvesting concepts for the drones, which they can have a sustainable flight in that extreme condition, an altitude of 35 kilometers to 75 kilometers. So we are looking at temperature-based energy harvesting, temperature difference energy harvesting. We are looking at the dynamic and thermal soaring, which happens because of the temperature gradients and the wind, the shear winds happening on the Venus, as well as in the solar. So we also have been looking at different types of jumping robots, which I showed some example there for lunar exploration, which this picture shows that. Titan which is Saturn's moon. So Titan has oceans of liquid methane. So this is the best picture that we have from Titan. And you probably are aware of that NASA, in the collaboration with the Johns Hopkins Applied Physics Laboratory and Los Alamos National Lab, they are currently developing a drone, which is called Dragonfly, and they plan to launch in 2027. But I met the team, and it seems that they have postponed their launch, and it takes 9 years to get the drone there, and they were expecting to have the drones in 2036. So this is a coaxial quadcopters or octocopters, which is Los Alamos National Lab is working the plutonium-based propulsion system for this drone. But one of their main concern is the way that for the entrance. If something goes wrong with the entrance of these drones to the Titan, I mean, they are basically using a nuclear material. They're saying it would be a disaster. So this is the reason we have been looking at some of the other types of concept, a virtual concept, which they can carry subsurface systems, because NASA, they are looking as a potential habitat or potential life in this oceanic world. They call it oceanic world. You know, there are also in Enceladus and Europa, there is a water in the subsurface that NASA is trying to develop some robot for those like moons as well. So the energy harvesting, the way the concept that we have proposed is that drone can harness that liquid methane with having an onboard oxygen and use that liquid methane as the potential fuel for that drone. So here we have been looking at the multiple way to harness energy from Titan to have a sustainable flight there in environment. So one of them is thermal soaring. This is a temperature gradient on Titan. It shows that in altitude 45 to 80 kilometers, we have a rising temperature. It's still cold, but the temperature increases. This is the patterns of the shear winds from the surface to an altitude of 100 kilometers recorded by one of these NASA missions. And then we have developed some sorts of algorithms in order to harness these winds to use dynamic soaring, which I'll talk about that later on, which is the way that albatross, they're flying over the oceans like non-stop through the just with harnessing the wind over the oceans for about a month, and they just sleep 2 seconds per night. So we have shown this feasibility study that it's possible to harness these available resources on Titan and develop a drone, a virtual drone, which can harness these resources there to have a sustainable flight on Titan. Mars has been in other planet that we have been focused on, and I'll show you a couple of projects that we have done for Mars. So this is one of the other bio-inspired concepts that we have done. So probably you have seen birds that they get a free ride of the other birds. So this is common in some birds and also crows with the eagles. There are two options here. So they can be really lazy or they can be really smart. So it can be one of this, why the birds, they show this type of behavior. Probably they are smart birds because crows are considered one of the smart birds between like probably 10,000 species that we have. So with looking at this, we actually proposed this type of concept for Martian exploration, which basically there is a drone which can carry to a smaller drone, which they can attach or detach or get a free ride from this bigger size drone. And that was one of the projects of my former master's students, that we have a drone cage here at New Mexico Tech, which we show this precision docking in a GPS denied environment. So here it shows drone in static mode. Would get close to this, would find out this sign, which is a thermal sign, and would be able to adjust its pitch, roll, yaw, and do the precision docking. And also I can show you in the dynamic mode, which basically we have this mimicking this fixed wing drone, and we want to find that spot and we want to do the precision docking in a dynamic mode. So here, I mean, these are like the technical parts, how we remove the vibration, how we control the roll, pitch, yaw of the drones, and we developed this type of software to monitor this in the real time. And this is our tracking system, which basically shows that how the drones is tracked by our tracking system inside of this drone cage to see this precision docking. We have done some research on the potential flight in the low dense atmosphere on Mars. Is basically see that how we can come up with some ideas that how fixed wing drones they can fly there. So I'll pass those slides. And this is one of the projects we have a proposal under review with NASA, is basically having this multi-agent systems of our robots to study the Martian lava tubes. So NASA is looking at the Martian lava tubes as a potential habitat for astronauts. So the main reason for this on a subsurface area is that because of the extreme radiation, they are looking at the subsurface. If they want to build their habitat, that's probably one of the spots that they can explore. But they have not been able to send any robots or rovers there because their rovers are huge. And then one of the satellites, which is orbiting around Mars, it has found like thousands of these open areas of those Martian lava tubes, or the better terminology, they call it volcanic caves. So our idea is to having these drones, which can carry this pillbug robot, would drop it into a lava tubes, and since they have the open entrances, there is a wind going inside of those lava tubes. So then this robot would be starting to disperse those dandelion seeds, and they start to collecting information like humidity, temperature, the wind speed there, the type of gases, and all of those. Send it to the main robot to the drone, and drone would send it to the rover. This is another project we did for NASA. So it's basically a new way of the locomotion. So we combined 4 different species characteristics to come up with the new way of locomotion. The lava tubes is basically a robot which can have this type of expanding arms, or having a launching sticky tethers to the walls of the lava tubes, and start to oscillating similar to the pendulum, and just remove from one side, have the other side, and then just move in the confined spaces. Here we have done some research in the simulated Martian environment, as well as in the dust effects in the robots, lunar and Martian dust, that how we can mitigate that. Had a team of undergrad students that work on that. So the lunar Martian dust, they both have magnetic characteristics. So here we have been looking at the mechanisms that how we can clean the dust or the solar panels of the rovers. So I showed you the other spider with the web, which launched the web. So this was another capstone project I had here in the undergraduate level. They actually designed this hexat, which is mimicking that spider with that web, and would be able to catch catch debris in the orbits. This has been a concept that we have been working on. This is our arena. This is a robot that next month we're participating in the NASA's competition. Is an excavator robot, is fully autonomous, which is supposed to dig into the ground and cultivate and extract this lunar regulus, and separate the gravel and collect those rocks on moon. And here I can show you a short video of this robot, that how we made this. This is one of our lab here at New Mexico Tech. It shows how students are building this robot, and this is also excavating on a lunar surface, simulated lunar surface. So I have about 25 undergraduate students from 4 different departments at New Mexico Tech that are currently working on this. Today actually was a day they presented to NASA, and they really like it. The approach that they built this robot. Let's skip those. This is their final concepts, and now they're improving this, which their competition is on May. So here, so these are all mainly master level projects and undergraduate level. So I want to go to the PhD level works that I currently have 6 PhD students in my lab that are doing research on biomimicry and energy for aviation industry, or for I mean any types of drones or airplanes. So you probably have seen the Bosque de la Apache. I'm also the board member of Bosque. So we work with them a lot, and we do research a lot there. So these are the type of the behavior we see in the nature. So we see the flock of the birds that they make V formation or echelon formations. We'll see the swarm of the small birds that they create a cluster swarm. We'll see the herd or a schooling of the fish. So there are multiple reasons that why animals, they show this type of behavior. So one of them is for finding food. And this mainly happens for the birds that are in the ocean. And then once one of them, they find the food, the others start to following them. Or if you look at the cluster swarm, the main reason of this behavior of small birds is to escape from predator, or to escape the predator, or again, to find food. So in the computer science, there is something called particle swarm optimization, which is an algorithm that has been developed for optimization based on this type of behavior. So, or it can be for energy efficiency perspective, which we'll see in the flock of the birds. So this V formation is well known for centuries, that why birds, they fly in the V. There are multiple reasons. One reason is that they save more energy, and another reason they want to see each other. But one aspect which was missing in the literature, and we were the first one, actually, we initiated this research, is that how we can basically look at them. And so, for example, Canadian geese, they fly 2,400 kilometers in a day and a half. They make this long migration, 1,500 miles. So, but what happens here, those birds, they are not the same. Some of them, they are juvenile, some of them, they're older, some of them, they have experience, some of them, they don't have it, some of them, they have a better level of health, some of them, they have lower level of health. So they are totally different. So how they decide who should be the leader, when they should switch the leadership. And one thing that we observed here, that we find out that they're working together in order to make this happen. So that was one of my former PhD students' dissertation project, that we did some modeling on them to understand the physics behind this and see what exactly happened in this area. So our results showed that the birds at the middle position, they save more energy than the birds in the tail or the birds in the lead positions. And that was really interesting to us, because we watched in the Bosque and also in the literature, we find out that this is exactly happening in nature, that the birds at the middle position, they switch with the birds at the tail or in the leader. And there are 7 management rules that researchers, they have inspired from Canadian geese. So how to do the load balance, how to help together to achieve something, when they should switch the leadership positions, how they can basically decide this, how they switch. So there are multiple like management rules inspired from Canadian geese. So here we did a study, and we find out that their energy efficiency, once they're starting to balance the energy between themselves, it can be enhanced more than 40%. So this is something we actually showed them how Canadian geese can fly 2,400 kilometers in a day and a half. So, and there is a 30% mortality rate on these birds, which actually we showed this, that the birds that they are smaller or juvenile and they have less experience, they have a probability to die. The birds that are older, they have flown longer, they have a less level of health, they also cannot survive. And there is a 30% of the birds usually cannot make the migration. And here, through our analytical solution, we showed this. So this is one of the video I captured in Bosque. We actually looked at them, that how birds, they make flock, how they are able to make the leadership. And I have 3 master students that are currently doing research on this area to look at different behavior of these type of birds. So we did some optimization in the wingtip spacing. What should be the optimum wingtip? So as you can see it here, there is a specific number that the birds, they adjust their spacing in order to fly in the V. So it's whatever we have done here, we have seen exact the same thing in literature, that is like about 10% of their wing spans that they have the overlap. If there is a more overlap and less overlap, they don't get the same efficiency. So what I showed you here, we did our model with a fixed wing, but the birds are not fixed, they are flapping. So our next step to look at more complex aerodynamics, to do the simulation with the flapping motion. So we did some like unsteady vortex lattice method approach to study this, and also we developed a setup with the lab made like the flapping wing, as well as with looking at some commercialized flapping wing, and then we build the setups to see how much load each bird they have during this types of motion. So these are a couple of pictures. If you be around Socorro, I can show you. We have a drone room and library, a skin library, which we have built a setup. And here I want to show you a couple of tests that we did. These are 5 flapping wing drones, which are in a V formation. And we did a couple of tests on them to see that how, depending on the position, they can save more energy. And we got exactly the same result as our analytical solution, and what like we saw in the nature. So these are attached to a load cell. So we measure the loads, we create the turbulent flow and also laminar flow in order to see that how this load would affect on them. And this is the echelon formation. This is the actual real sound of these birds once they're all working. And our study showed exactly what we were expecting. So here this shows the thrust, not the drag. So this shows the birds at the lead position is going to have less thrust. It means it's consuming more drag. And the birds in the tails, they save more energy. So we did a couple of tests. We did a battery drainage test to see that how this can verify this. And actually, since all of them are the same battery, same power, so we got a very interesting results here. We have done some flow visualization in underwater as well as in the air, which I can show you here with the laser and fog. We show that how this vortex happens here around this flapping motion, and with the interaction of the multiple flapping wings, how this airflow is moving, and how this upwash and downwash effects is affecting in the optimum spacing between these birds. So this is basically some simulation and this imagery velocimetry that we have done with this type of flapping wings. So now from formation flight, I want to move to another concept, which is a coloration. So if you ask biologists why birds have different colors, they have 2 answers. They want to attract mate, or they want to do the camouflage. But if you look at the migratory birds like albatross, sooty tern, black skimmer, shearwater, they all have black color at the top, and they have white color from bottom side. So we are all from New Mexico. If I go out, I have a black shirt. If I go out during summer, I feel more hot than having the white color. This is exactly the same happens here, that through the evolutions, the birds, they pick these colorations. So the top color is black. So black color is absorbing heat. So it's hotter than the white color. So that would change the airflow around them and would allow them to gain more lift and have less drag. And we did a couple of testing. And then like a couple of months ago, we published a journal paper about explaining why all of those birds, they have different patterns of color. So you have a zebra pattern here. Some of them, their trailing edge is black, some of them wingtip. So each one of these colorations, they provide different flow patterns and different aerodynamic characteristics. So this is a study we did in wind tunnel. We have 5 wings, and then we increase the top surface just 10 degrees Celsius temperature difference. And this is a lift to drag ratio that we got. It's more than 150% in low Reynolds number. And here This is a black and white color wings. Once you expose them to the simulated sun radiation, their temperature difference is 25 degrees Celsius. So right now we're working with Sandia National Lab, and they are going to provide us a higher speed wind tunnel to do this for larger size wings, because we want to implement this to aviation industry. So this is another like CFT analysis and experimental study that we did with different patterns of coloration. The main reasons that biologists are explaining about the coloration of the wingtips of the birds is that the black color is coming from the concentration of melanin. And melanin usually increases the strength of the feathers. And that's the theory from biologists. But we know that there is a temperature difference between black and white color, and there is a vortices happens and downwash and upwash effects in the wingtips. And our hypothesis difference is that black color changed the flow patterns in wingtips and would allow them to save more energy. And now we have a pending patent to apply this to aviation industry, to just instead of randomly colorize the wingtip or the winglets of the planes, make them with the black or a specific color patterns, which basically would allow them to save more energy. So monarch butterfly, this has been another research that one of my current PhD students is doing. Once I was working on the coloration, I published a paper on the monarchs, because a paper published in 2011 that the monarch color, that they have more darker color, their survival rate is higher, and they can make this long migration from Canada to central Mexico. But the guy didn't know the reason. I published the paper. The guy from University of Georgia reached out to us, biologists. We started to collaborate since last 2 years, and we got a very interesting results, which I want to show some of them. So the monarch butterfly, 75% of them is basically black color. There is a very small amount is a white or gray spot. The rest is an orange color. So here, the behavior that we see, that they are receiving sun radiation. Black color is hotter, and these are all the thermal imaging that you will see it here. But one of our, we have a paper with the journal right now, is going to be accepted soon, is the guy actually sent us 50 live monarchs, and we had an exhibition at Tech during the 49ers event 2 years ago. So if you look at this thermal imaging, you will see the black color is hotter, the orange color is transparent. But the question is that, what are those white spots? Why they have developed those white spots over their wings? And then we started to do research on this for different species of monarchs. And the one that are migratory, we said that they have larger white spots. So what is the theory behind this? So what we did here, this black and white, definitely it creates the flow patterns change in the trailing edge. So it has some aerodynamic effects based on our past study. But in the same time, there are natural and live species. So we colorize the live monarchs, this white spot, with the black Sharpie. And we expose them to the sun, simulated sun radiation, and we saw that their body temperature increases 2 degrees Celsius, which these are live species like us. If you have 2 extra degrees Celsius in our body temperature, is basically a fever. So these are thermal regulator. So these white spots, they are near their veins where the blood goes, and would allow them to regulate their body temperature so it's not overheated. So this is a new funding for this research that we are going to publish it. Killer whales, dusky dolphin, penguins, they have the same pattern, black and white, same story here. Story short, the same concepts here. Penguins, they have the same concept. This work was done by a middle school student from Socorro Middle School, and she presented this work at AIAA Proportional Energy in 2020. We actually explain why penguins, they're also picking black and white from the energy perspective and how they can save energy here. And this is another behavior. I showed you the birds, how they make the V formation. This is another behavior we see in the nature with the penguins they are doing. So penguins, they do the huddling, and they create a wave, and they start to switch. So there's no penguin left all the time in the outer space because they are exposed to high-speed winds and also extreme like temperature. So we built an experimental setup. We did some experimental study to optimize and explain this, how this is going to work. What is the wave frequency that those penguins happens? How does their locomotion can be related to the heat transfer or thermal management between all of those penguins. So I was talking about thermal soaring. This is a behavior you will see probably in New Mexico birds in the helix way. They just go up with just using the rising temperatures and thermal gradients. So one of the projects we work is if you want to use drones for monitoring the solar farms, those current drones, they cannot fly more than half an hour with LiPo batteries. So what we have been doing is to develop some control algorithms on the drone, which they can harness energy from the 20% energy of the received energy by solar farms, they will be reflected to the air. So that would create these heat fluxes. So now we are looking at how we can have a sustainable flight for 6 to 10 hours over the solar farms to monitor them. We have done some research on amphibious drones. The drones can dive into the water, like flapping wings, swim under the water, or the drones can carry on the water robots. For these drone hubs, we have looked at the water lilies as a potential solar collectors concepts. So these are the drone hubs that we have developed in order to have a sustainable flight in the marine environment for oceanic monitoring. We have been looking at the ground effects for this type of drones in order to carry more weight, or those like UUVs or underwater robots. We have been working, one of my current grad students is doing camouflage drones. The taxidermy birds, which I'll talk about that, was actually related to this project. So you probably have seen lizards, once they're in the danger, they sacrifice their tail to rescue the rest of the body. So one of my former students, we developed a drone, which if there is a part get damaged, still can be separated, and the rest of the part can be still a drone and continue the mission. We are right now building a camouflage drone. Drone can change the color depending on the environment that they're flying. There are 350 algorithms that they have been inspired from nature for optimization. This is a book that currently we are writing that we are trying to map this optimization algorithms in application in aerospace industry, specifically on drones. So some of them are terrestrial, animal, microorganisms, insects, birds, avians, and so on. Smart city, this was one of my NASA projects to integrate drone technology to NASA's facilities. So here, we are looking at how we can integrate drones to our cities. And this is a concept that NASA and FAA, they are looking at, that's called advanced air mobility, that how drones can be used for transportation in the future. So we have been looking at the nest of the birds, the hives of the honeybees, and we propose a concept of the drone garden. So it's basically we are developing a tree-inspired vertiports for the drones, which they can be integrated to our cities, and they can house the drones, they can charge the drones, protect the drones, deploy the drones, and dump the data and all of those. So we are currently building one at New Mexico Tech. Drones for structural health monitoring. This was another project we did in order to inspect the airplanes. And these are two of my funded projects. Last week I was in California. We actually built the first permissible drone for underground coal mines. So we have a project with the Alpha Foundation, which we are developing a drone which can fly in an underground coal mine. So you know that MSHA, which is Mine Health and Safety Association, they have a very strict rule in order to use any electronics in the coal mines, because there is a extreme conditions there. It's dark, it's dust, it's a methane gases there. So everything should be intrinsically safe or permissible. So here we have developed the first permissible drone, which is using a unique way of proportion system for this. So this drone is enclosed in a composite, which can basically tolerate 150 psi inside, and the motors are attached by they are using with the magnetic coupler, so they're not directly attached the propellers to the motor. So through magnetic force, they're rotating. And this is the first flight test that we did last week in California with 2 of my PhD students and my other colleagues from University of Texas, Arlington, and mining department here at New Mexico Tech. This is another concept we are doing. This is one of our biggest projects here at New Mexico Tech. It's a $4 million project we have from NIOSH CDC. We are developing multi-agent system for underground mines search and rescue. So it's basically, we have a robot and a drone that we want to use them during the accident in the mines. So we have built actually a couple of prototypes here, which would do this deployment. And here, this is our new one, which is mimicking the turtle shape for this box, which basically can make the SLAM navigate itself and deploy the drone. And these are the 3 drones that we have made for these projects. And this is our robot that currently we're working on that. So I'll skip those. We also do some virtual reality stuff for this project that we want to do some research on human subject with the cyber sickness with the VR, how we can train the mine rescuer to use this technology to during the search and rescue in the virtual reality. And this is one of my projects that got like all around the news last 2 months. We actually presented this work in AIAA SciTech this year, and new scientists reach out to us, and now is everywhere. So if you want to use drones for wildlife monitoring, drones create a lot of noise. So animals will be scared and scatter. So we are developing the first nature-friendly drones. We just re-engineer the taxidermy birds and make them flyable again. So for this project, I mean, we got a very negative comments from the people. Why did you kill the birds? And why did you do this? I said, no, we didn't kill any birds. We just purchased wings, feathers. We work with the taxidermists in Albuquerque, and we want to help wildlife, not just hurt the wildlife. So these are multiple concepts. This is one with the pheasant body and the pigeon's wing, show actuation mechanism. This is another concept with the pheasant feather and pheasant head. These are the crow's wings. And I want to show you a couple of videos. And the main reason that we are doing this is that birds, they don't understand this is bird. And you probably have heard about this conspiracy theory of the birds are not real. So actually people that are believing on this conspiracy theory, they get connected to our project as well. So here, these are actual wings that are much more efficient than the current wings, artificial material for the flapping wing that we're currently using. And this ended up in the Stephen Colbert show. I mean, he made a very nice comment and joke about our project. I played this.
We have power packs. We have a power pack show tonight. A young lay searchers are turning taxidermy birds into drones, which could be potentially a very useful espionage tool because it will look more like the real thing and hopefully is more inclined to be ignored. Maybe ignored by spy targets, but what about the other birds? Oh my God, Phil, we thought you were dead. Hey, everybody, Phil's back. Phil, it's me, Mary. I love you, Phil. Don't you recognize the kids? Got kind of dark there at the end, didn't it?
So, and this is the couple of flight tests we did with this flapping wing. So it shows the full flight of this. So we had an interview with Reuters 2 weeks ago, probably will be out for the second round again next week. So my students running that bird, so it was going toward the trees. So this is a new one that we have built. We haven't tested yet. So it's using another types of feathers. It's a fixing model with just dead part of the birds. So that was all for research. Here, I am teaching classes from the elementary level to, graduate level. We do lots of outreach. I have a drone program for high school, which basically in 5 days, they will learn how to design and build drones. These are some of the summer camps I have done in Española and Santa Fe, like 2 summers ago. These are all the design and airplanes, drones made by those high schoolers. We do also training for teachers. I have trained like 200 teachers across the state through online workshops and in-person workshops. They learn drones in 3-4 like lectures and 1 full day like workshop. This is our drone facility, a small drone like cage and drone room here at New Mexico Tech with virtual and augmented reality, which we are using for outreach, for teaching. This is a small platform that you can connect it online to that, and you can fly drones online. This is last week we got $650K capital funding from a state to start a drone institute here at New Mexico Tech. And then we will be having a building here with a 3,000 square feet, as well as a huge drone cage, which we are right now looking at between something like 12,000 or 24,000 square feet, with the 45 feet the height, which would be a facility that we will be able to fly any types of drones there, as well as a runway, which we will have for different. And we want to also have a drone racing competitions here in the future in this facility as well. These are all my funding agencies, which I need to acknowledge. And I think that was all. So if you have any question or something.
Well, that was in presentation. About some of the drones on Venus. You had a picture of a balloon sort of probe with lots of discs hanging from it. What were those? Do they?
So that was the
catch
jellyfish
or-
inspired that I was talking about. Venus has a very high dense atmosphere. So if you have any types of the balloons, it's going to work there easily because they get enough buoyancy there. So we have been looking at developing this type of concept for the mid-altitude flight on Venus, which also can drop those microorganisms into the surface, because surface of like Venus, it's a 56 kilograms per meter cube is a density, about 50 times more Earth. So we have been looking at this type of jellyfish like drones, which can deploy these smaller robots toward the subsurface.
Fascinating. I had another question. Are there any programs on making drones that the average citizen, like we have a friend that visits us from Albuquerque, and he's got a drone. He loves it, but I think he'd be fascinated if he could go to one of your high school programs. Is there anything for just the general public?
Yeah, absolutely. So I do a lot of outreach activities. So this coming summer, I have 2 mini classes for high schoolers, 2 our summer STEM mini classes, and I have one free workshops for 100 teachers probably during the summer, that they're coming from northeastern part, the southeastern from the Roswell area, and other school at university is handling that. So yeah, I mean, anybody's interested is free to join. I can share
You don't have to be a teacher to participate in that program.
No. I mean,
Okay.
it's between me and the teacher, so it should be fine.
Well, yeah, I'll look into that. Sounds great.
Any other question?
Hi, Mostafa. I was just at the Q station today, and I ran into Chris Dinelli.
Oh,
who,
yeah.
Yeah, he showed the that mining drone with the turtle drone with the drone inside of it. Yeah, it was very, very interesting.
Yeah,
So,
he's actually working on a NIOSH project. He's my PhD student working on that concept which I showed you.
Okay. Yeah, he started with RIA Space Activity. Yeah, so we met with them, and then also Andrew Torres. He had taken a class with you. Yeah, so they knew each other a little bit, but anyway, they met for the first time today at the Q station.
Oh, cool.
So yeah, small world.
Yeah, that's great.
But I was impressed with the variety and the range of the types of drones and the applications. It's just amazing. You're all over the place. And I've been reading about the undersea oceans and the moons of Jupiter and Saturn. Have you been looking at those environments?
Yeah. So on Titan, actually, I have my former grad student. She worked on that. She did her thesis on that with the energy harvesting aspects. And I have another master's student. She's currently looking at Europa and Enceladus for oceanic water to develop a swarm of the aquatic robots, which they can be deployed into the subsurface because there is a water there.
Yeah, amazing. Yeah, fantastic.
Thank you. Yeah, I have graduated 13 master and PhD last 2 years, and this semester I have currently 6 PhD, 8 master, and I have hired 6 PhD for next semester and 4 extra masters. So I have a big group, research group here. So there's all my students working on presenting. Basically, work.
Do you sleep at all?
I mean, that was a question I got during my tenure review in the second year. They were asking me why you're publishing too much or like spreading. I said, I'm living in a small town. I don't have wife. I don't have anything in my life. I'm living in a small town in Socorro. That's all that I can do. So there's nothing else to do in Socorro.
Yeah.
Yeah, so.
Mostafa, are you familiar with the waste isolation pilot plant in southeastern New Mexico? They call it WIP, the WIP site. Have you heard of it?
Yeah, for the one that they do the nuclear stuff, right?
Yes.
Yeah, I actually have met one of the guys in Carlsbad when we visited mine. I forgot his name. But yeah, I know that they are also interested to use drones for inspecting their facilities as well. And one of the application of our permissible drone can be for this type of things.
Yeah, I think that would be a fertile application for something that's in New Mexico.
Absolutely.
And also a DOE owned facility, I think it is.
Yeah, that's right.
Another question is, have you ever studied the interaction underground between the very small tendrils in trees versus the fungi that are also in the ground? They will communicate back and forth.
Yeah, I have heard about that. So I have right now a student, he's doing research on navigation and communication in GPS denied environment. And one of the area we're looking is the biomimicry aspects. So for undergrounds, or for example, how scorpions, they catch their prey through this acoustic wave, which they're sensing with their legs. Or another example, we are doing that the bumblebees, they are using the magnetic field of the flowers to exactly land over the flower. So the way that the bumblebees and the flowers, they also communicate with each other through this magnetic field, because there is something in the biology called mutualism, that animals, they both take advantage from each other. This is like the flowers and the bees. So yeah, we have been looking at all those concepts to get inspiration to use in our drone projects.
Fascinating. I really like the stuff you had on the crane flight and how that sort of optimizes energy. And of course, we have the Bosque del Apache just down south, and it looks like you had some great footage down there.
Yeah, actually, yesterday I joined them officially as the board member of the Friends of Bosque.
Oh, great. So yeah, I was gonna suggest, you might give a talk for them during the Festival of the Cranes in November.
I actually did the three talks
You've
last
done that.
year. Yeah, I did a 3
Excellent.
workshops for them last year, and we were going to have also on May, there is a spring event that we will have as well. So we have a couple of speakers that are coming. I can send and share the link for registration if you're interested. It will be a really nice talk that we will have.
Yeah, if you email those to me, I can send them
Sure.
out to everybody.
Absolutely.
Yeah.
We're always on the lookout for more people to do Zoom meetings. And I was thinking that some of your students that have individual projects where they've done the project and built things and all, they might be willing to try to give their own Zoom meetings to us. And get some
Absolutely.
experience
That
that
would be
way.
fun.
Sure. We definitely can do that.
All right. Okay, any more questions? That was a thoroughly fascinating presentation. I really like the part about the color. I really hadn't thought about how the color of the wingtips might be an energy innovation.
Yeah, it was actually a work that we initiated for the first time. So now lots of researchers are following our work on this area.
Neat stuff. Okay. Well,
Quick question, is that color difference of darker on the top, lighter on the bottom, that occurs in fish for camouflage purposes, but does it also have the thermal effect?
So there are like, I think I showed it. There is a killer whales, dusky dolphins, some sharks, that penguins, they are not swimming in the depths. They're swimming so close to the surface so they can receive sun radiation. And that's another explanation that we had. For the
Okay.
camouflage aspects, yeah, there is another like part of that. So what we are now looking for the birds is that there are multiple reasons. So
Right,
we
right.
and we want to look at the percentage of
That's a good question. Very good question.
yeah, we are looking at so some of the birds, they might be just more toward camouflage, some of them more for energy. So we are trying to relate this to the place that they are living, as well as their amount of radiation receiving, their flight frequency, flapping angle, their sizes, their weight, and all those aromatic data that we have from the birds.
fascinating. Okay, looks like that's it for questions. That was a splendid talk. So yeah, we'll stay in touch.
Yeah, thank you for having me.
All righty then.
Yeah, have a good night.
All right,
Thanks.
well, everybody, take care till next time. We'll have another fun meeting in May. We'll school will be finally out, and I'll be able to come out from my busy little cloud there a little bit. All righty, well, take care, everybody. Have a great rest of April, and thanks so much for speaking to us.
Thank you for having me. Have a good night. Bye-bye.
Oh, okay. Take care, everybody.